Hey everyone, it's Ben from Board to Bits, and welcome to part 12 of our series on making custom 3D meshes in Unity. So now that our voxel classes are able to look a little bit more critically at our voxels and their faces and their neighbors, we can actually start building our voxel structures with only rendering the faces that we need for them. So let's jump over to MonoDevelop, and I want to take a look at something here in our voxel data class and in our voxel render class, which is that it's important to know that all of this stuff is in sets of 6 here. We've got our set of 6 directions, our set of 6 offsets for looking at our neighbors. In addition, in our make cube method, we are iterating through and making 6 faces. And that's really important because as long as you have the same number of these elements and they're in the same order, the order itself doesn't matter, but be consistent with your order. In our case, we're going north, east, south, west, up and down. As long as you have that, you can start referring to all of these different sets of information by our plain English enums, which makes it a lot easier to kind of understand what's going on inside of our program. So the first thing we're going to do here is inside of our make face method, instead of just calling an arbitrary integer and having to remember what each integer means, we can actually call that direction. So instead of making face 0, we're actually making the north face of our cube. Now we do also have to now convert this integer here that we're iterating through into a direction to pass that in properly. So we'll just cast that by putting direction in parentheses right before the I. We can save that. Now we're already in, once we hit that point, once we're starting looping through this, we are referring to our faces now in this plain English directions rather than integers. This does run into a little bit of an issue though, because down here we've got, the first thing we're doing is we're getting our vertices from our cube mesh data class, and the problem is that this, you're going to notice there's kind of an unknown resolve error, and that's partly because this is, we're passing in a direction, whereas face vertices really wants an integer there. Let's actually, if we right click here and go to declaration, that'll open up that script for us. And we can see right here, face vertices wants an integer. Problem is we can't just change this directly into a direction because we've got other classes like our procedural cube class that doesn't know about directions right now. It's kind of naive and it's kind of happier that way. And if we were to change this to a direction here instead of an integer, Unity is going to start throwing errors at us saying that there are these other classes that are passing in the wrong information and it can't run our program, and we'd be kind of stuck. So we need some way to solve this because we don't really want to have to cast this back in our voxel render. We don't really want to cast this right back to an integer right now. We've gone through all this trouble of making it a direction, making it easy for us to understand. Going right back, the second step of our process here, going right back to an integer, feels kind of like a defeat. So fortunately, there's another option that we have, which is we can actually give our different classes different options of how to interact with this method. And that's called overloading the method. If you haven't heard of overloading the method, it's basically this idea that you're going to have two versions of a method. They have the same name, they're returning the same type of information, but you can pass in different information. It's perfect for this situation because we have one class that knows about directions, one class that doesn't, so we're going to give options for both of those. How we're going to do that is we're just going to copy this entire face vertices method, copy it, paste it down here, and the only thing I'm going to change right now, the first thing I'm going to change at least, is I'm going to change this to direction. So now we have this new version of the method that takes in a direction. However, we do now at this point need to somehow cast this to an integer because ultimately we are dealing with arrays, and arrays need integers to get their information. So it's not, it still feels a little bit contrived in this situation, but what's really important about it is that we're creating this kind of syntax of these plain English directions so that we're not ultimately always falling back on having an integer we have to try and understand. Like, as you get more functions in here and you're dealing with these directions, you'll really appreciate when it says, oh, the west face has been hit instead of face 4, and you're trying to remember which direction does that mean, etc., etc. Now the other thing we can do here, now that we've overloaded this method, is we know that these are going to do the exact same thing. They're going to create an array, they're going to iterate through it, they're going to get the vertices from our face triangles, and then ultimately pull the vertice, and then fill in this array, and then return that array. We can have these both say the exact same thing here. We would just need to cast this direction to an integer again, so it's working with the array. But it's not ideal to do it that way, in my opinion, because it makes your script a lot longer, and it's going to be kind of clunky. And suddenly you're kind of rooting through stuff and trying to find where, if there's a bug, you have to try and find where the bug is. You got more lines of code to go through. In addition, if I was to change something in this version, I need to change it in this version, so on and so forth. However, what we can do instead is, since we have this original version of the method, we can just have it do the work for us. What we can actually do is we can get rid of all of this information right here, and instead just return face vertices and pass in this original structure. So here's where we're going to cast this direction into an integer, so it's this version now. We'll say int direction, and then we can just pass in scale and position as they are. And now what's going to happen is we ask for face vertices with a direction, which then asks for face vertices with an integer. This ultimately returns the vector3 array, which returns it here, and we'll pass it back to our make face method. So with that, now we're, like I say, we're sticking with this syntax that we've created. We don't have to flip back and forth between integers. It's all done behind the scenes for us. It's pretty cool. Now with that done, all we really need to do is now make our actual choosing of when we make faces a little bit more intelligent. Right now we're just making a face for every single side. What we want to do is we want to use that getNeighbor method that we created last time to look at our neighbors and say, hey, if there is a cube here, I don't need to make a face because it's going to be blocked. If it's open air, I need to make this face because that's what the user is going to see. So the problem with that is that right now, once we get to our makeCube method, we have all this great information for rendering a nice cube, but we don't know about our data anymore. We've kind of left that behind, and so we need to add that back in here. We need to add in the location as well as the full array of data. So we're going to add in an integer for x and an integer for z for our position, as well as our voxel data, which we'll just call data again. And then we need to make sure we add that up here in makeCube in our actual function call. So we'll just pass in x, z, and data, because that's what we were passing them in as up here, or that's what we had passed in data as, and then we're iterating through our x and z loops. And now with this added information, we can actually intelligently go into our data and then call our getNeighbor method to see, is there something next to me in this direction? So for that, all we have to do, actually let's look back at that for 1 second again. See, we're asking for the location, just the location, as well as the direction. So we can do that easily enough. We can say if data.getNeighbor, we'll pass in the x value and the z value, and then we can simply pass in that direction, which is going to be direction I. Because at this point it's still an integer for us, so we do have to cast that there. Now if it is 0, then we need to make the face, because that 0 represents open space. If it's 1, then it's solid, we don't need to do anything. So we can just check, is it open space? Does it equal 0? If so, we will make our face. If it's not, we know that it's covered up and we don't need to render that particular face. And with all that, you can save that there, and we should be able to jump back over to Unity, hit play, and let's see what happens. Remember, we're in the wireframe view of our scene, so we'll actually see if there are hidden faces inside of the structure. But let's hit play, and I think, sure enough, we see that it's nice and clean inside there. In fact, this is actually showing kind of the back face culling, and that you don't see even the back faces or the bottom faces. such that we have a very clean cube now, or a set of cubes now, that aren't rendering all of this inside grid structure. So with that, that's really how you make voxel structures in your game. You take that data and then you convert it into cubes, but kind of possibly only half cubes or even less, depending on how many faces you need for each cube. So that's really going to wrap up the voxel side of things here. We are going to look at extruding shapes. I may wait until the new year to do that. I want to finish up the character controller series that I'm doing as well, and that's going to be a little bit more involved for the next couple of weeks. But we'll definitely get back to the extrusion. Really, you have 99% of what you need for that here. You can create, shapes with your triangles and quads, and then you're really just creating kind of a ring of quads around that to make that flat shape appear like it's stretching out. But like I say, we will definitely go back to that. It just might be a little bit delayed. If you have a really strong need to see that sooner, if there's something that you're working on, please feel free to email me or message me on Patreon, and I can certainly look at helping you out with that sooner than when I get the videos up. Thanks so much for watching, and I'll see you next time.